Okay, we're here for another talk on the Perspectives in AI series. It's a very big pleasure to have Professor Vazirgiannis here with us. Professor Vazirgiannis has a very long short bio, so I will try to summarize the short bio. He's a distinguished professor at the École Polytechnique in France. The École Polytechnique in France was the inspiration for our Polytechnic school here, where I work. So it's very nice. He's been involved in many projects in data science, AI, LLMs applications in many different languages. I think he will say a few words about that. Many dialects. He's published more than 250 papers in many different venues, NeurIPS, C4AI, and all the AI top conferences, and supervised 35 completed theses. This is a lot of work. So it's very nice to have you. He will talk about sovereign AI, sovereign LLMs, which is a topic that is really interesting for us here in Brazil. So a lot of discussion on that. So Professor Vazirgiannis, please.
Thank you very much, Professor Grossman, for the nice and kind introduction. So it is nice to be with you in this excellent campus with this brilliant weather. So I will be discussing today on the concept and the practices of sovereign LLMs and our experiences in this area. The talk is not that technical. We will not see a lot of math today because the topic of LLMs has also socio-economic and geopolitical aspects. Feel free to interrupt me whenever you want. So this is going to be the structure of my talk. I will introduce basically the concept of sovereign AI, what sovereign LLM pipeline could be, and I will present two efforts that we did recently on sovereign LLMs, the Atlas chat and the Nile chat, which are LLMs that are speaking and understanding the Moroccan dialect and the Egyptian dialect of the Arabic language. Just to put things in context, the LLMs consume a lot of data. Here in this graph, we see how many words, how many tokens we needed to train GPT-1, GPT-2, GPT-4, and we see that this is a logarithmic scale. So we see that the amount of data that are needed to train an LLM are extremely large. It is interesting to see that a human in their lifetime has read or produced or heard up to 1 billion tokens or words. The English Wikipedia is a bit, let's say, larger. And all human, let's say, produced text is 10 to the 13th, which is roughly the amount of data that we need to train an LLM. There is an estimation that in August 2025, a few months ago, the synthetic data that have been produced by LLMs and other processes have superseded this amount of data, the total amount of data produced by humans in history. And now there is this this interesting case where we see that technology adoption leads to let's say, sovereignty and also higher GDP with all the good consequences. So we have South Korea and Philippines that back in the 60s, they were two poor countries, mainly agriculture. And at some point, South Korea made a huge investment and strategy on adopting technology. And we know South Korea today is very well known for producing chips, screens. I don't know if this is a Korean screen. They are producing ships, cars. So they have heavy industry, okay, including chips. So you see that throughout the decades, South Korea made a huge difference, and they blame it to the adoption of technology. So this is an indication that if there is a long-term policy of adopting a technology, this can be very beneficial for the country that does it. And what about AI? Here we see the rate of adoption of different technologies throughout history, let's say. So we see that electricity took about 25 years to occupy 40% of the space. Internet, smartphone, cell phone, etc. And we see that the pace of artificial intelligence is much faster, okay? So it means artificial intelligence is very penetrative and is being adopted faster than previous important technologies. There is also this interesting visualization here on how adoption of AI is compared to the GDP, to how rich is a country, to the gross domestic product that is being produced. And we see here that countries like Singapore and United Arab Emirates, this is GDP per capita, okay? They are very advanced in this case. We see countries like Norway and Ireland being there. So there seems to be a correlation between the GDP and the adoption of AI. But let's see, what do we mean by adoption of AI? There is this colored map that tells us what percentage, what proportion of the population is adopting AI in their daily processes, in their daily jobs and activities. We see that the champions is UAE with almost 60%, Singapore, Ireland, we have Norway and France, Canada as well. And we see that there are many areas in the world that are lagging behind. Here, if we want to see specifically for Brazil, if we trust this report, it is at 15.6%. And this is a proportion of people, of the working people that adopt AI in their daily work. But when we talk about AI, what are the building blocks? What do we need in order to, let's say, build sustainable AI systems? The first of all is that we need electricity. We know that AI is very hungry for energy. There are some estimations that already AI accounts or consumes 1.5% of all the energy that is being produced worldwide, which is already a huge amount of energy. And there are criticism in the sense that this increasing consumption of electricity with AI will have effects on the other sectors of economy. We also need data centers because we need storage, we need cooling, we need GPUs, and all this is an important and critical infrastructure that needs to be working around the clock. Apparently, we need internet, high quality, fast internet, so that this all works. This is no-brainer. We also need digital and AI skills, which means that we need the people that will function these data centers, will train LLMs or will train AI and will create the ecosystem that will create the added value for the economy and the society of a country. And apparently, there is the language, which is critical, as we will see. Language in terms of how many resources in this language are available in digital form to train AI. So because we discussed about data centers, this is the distribution of data centers across the world. We see that there's a big concentration in US and China, Europe and also Brazil is on the map. We discussed about language, okay? Language is the tool that we use in order to communicate with others. And in digital form, it is the main modality, text, to use for training models, right? It seems that the proportion of English, even though English is natively spoken by a much smaller proportion of humans, I don't remember, but it is it must be around 500 million people or 600 million people that speak English as a native language. On the digital content, English, for different reasons that have to do with science, commerce, geopolitical reasons, is very significant and very dominant, okay? We see Portuguese somewhere there. This is the proportion on digital content. And for some languages that are widely spoken, like Swahili, for instance, that is spoken by 200 million people, the absence of digital content makes it impossible to participate in AI, right? Because in order to train AI, you need digital content. For some different reasons, Swahili doesn't come with digital content. And for this reason, it is absent from the AI landscape. So the takeaway from this slide is that in order that the language participates in the AI revolution, needs to have digital content, be it text or speech or images or videos, etc. Of course, yes.
So when you say that, like English native speakers are like,
I guess.
but like if you count India, I think it's.
But India is not a native language. In India, there are 28. I mean, if you count as well, but they have their own official language, which is Hindi, and then each one of the states has its own official language. Yes, this is something that is missing. I have to say that, yes. Of course, I am not sure how much this is representative of the reality, because the Chinese digital reality is behind the wall, and we don't really have access to. I guess this mostly represents the that we wear the Western world glasses, and this is what we see. Okay, I think these are indicative, but we cannot trust 100% exactly the numbers that we see there. It is an indication. But I think it is common sense that English is dominant. This is why I'm giving this speech in English, and most of the papers, all the papers are. Even Jensen Huang, who is the CEO of NVIDIA, that we know it is a hugely important company. It is the dominant company in designing, developing, and selling GPUs. Their capitalization exceeded $5 trillion, which is an unprecedented event in economy. So he said that every country needs to own the production of their own intelligence. It codifies culture, society intelligence, common sense, and history, and you own your own data. That was back in 2024 when he was participating in an event in United Arab Emirates that was about artificial intelligence. So the question is, why do we need sovereign AI? The list can be very long. I tried to densify. So there are economic benefits, national security, cultural preservation, and also participation in global challenges. The economic benefits apparently have to do with the added value that is producing AI because of automation and all that. We have even now the figure of trillions. I just mentioned that the value of NVIDIA alone exceeded $5 trillion recently. It is boosting productivity across different sectors because of automation. We can imagine industry, transport, even agriculture, which is a very important sector in Brazil, and creating a competitive advantage at the level of international digital economy. In terms of security, having sovereign AI, as we will see later in future slides, it is helping to protect national interests because, for instance, as we speak, my talk is being streamed via YouTube, which is a US service. In the unlikely case that US decides to switch off these services, we go back to the Stone Ages, right? So This is an important parameter. Security, reliance on foreign AI technologies, access to critical infrastructures like GPUs, data centers, and protection from supply chain disruptions, which means that if you have a local industry, you're not affected so much about what happens abroad with regards to supply chains. Cultural preservations, I think this is even more important for Brazil with all these indigenous cultures that there are here, plus the very rich version of Portuguese that is spoken and evolving by more than 200 local Brazilians. Huge, I guess, cultural production of text in government, in economy, in health, etc. And there are also global challenges. Participating in the AI revolution, one can participate on making AI more sustainable in the sense that if a country has an advanced AI technology, they can evolve, they can change this technology towards more energy efficient approaches. Okay, so what are key aspects of sovereignty in this case? We start, of course, from the hardware. There is no doubt that you need to have your own hardware so that you don't depend on external resources, and also data centers within national borders. The next very important aspect is to have control over data assets, which means that the training data need to be collected, stored, and governed locally. And also anything that has to do with culture, local values, local civilization is very important here. Language, history, values, they are local and need to be treated locally. Okay, this slide is a little bit unreadable, but I will try to give an example of localization, how AI can be adapted to. For instance, I submitted the query today at Gemini. How can I issue a driver's license? And there is a long list of processes, but it is about US. Okay, and the query was done in Sao Paulo. The same query for ChatGPT was successful. So it gives, I guess you, it is in English, but you see that the process is the local one because it detected that I am in Sao Paulo. But then, even though ChatGPT is detecting the local aspect, it is using RAG, apparently, retrieval from local sources. But the question is, do you like, or can you trust an external entity that has so deep access and knowledge to your local national resources and knows the process of getting the driver's license probably much better than most of the local people? Some other aspects of sovereignty. So we discussed about hardware and about data. The next aspect is about models and algorithms, which means that the model that we develop locally is sovereign in the sense that we control it. So the idea is that we own the model. So as we will see later, either we train from scratch, which is not advisable because of the huge amount of data and engineering needed. But what we can do alternatively is to fine-tune an existing open model that we control 100% with our own algorithms that comply to national laws and ethics. Another very important, let's say, element in this discussion is about human resources. In order to develop all that, you need local skilled engineers for different purposes. We need researchers that understand very well the whole AI pipeline. We need data scientists and highly qualified engineers. I can tell you by experience from our, let's say, recent experiences that highly skilled engineers is a key factor for successful development of an LLM that is competitive internationally. The good thing is that if we succeed in that, then the nation can maintain this human capital that will multiply itself and create a sustainable AI ecosystem. And then at the level of policy and regulation, there are legal and ethical frameworks that can be imposed on the AI systems and can regulate how AI is used within the borders, something that now is very difficult to apply because the AI comes from outside. Let alone that the data that we produce daily, the prompts that we give to OpenAI or to Gemini, or the data that we produce with our smartphones, talking, moving, doing transactions, we donate them for free, and these data are being used to develop the next most competitive generation. Some examples of what does it mean to be dominant in AI. We all understand that US is the dominant key player in this area. It controls about 80 to 90% of the global market of GPUs. That is controlled mostly by NVIDIA. There is recently an effort by AMD with GPUs that are performant, but the problem is that the software is not compatible with the ones existing. So, but this is improving. There is also other players that have supercomputers like Cerebras, which is a supercomputer design in California that they advertise having very fast inference. With regards to cloud infrastructure, we all know AWS, Azure, Google Cloud, that they are the de facto key players in this area. With regards to foundation models, LLMs, depending on the measurements, between 80 and 100% of the usage of LLMs belong to US companies. And also, in order to create such excellent AI, you need to invest a lot of money. So the venture capital that was invested is more than 50 of the global private equity that has been invested in AI globally. So with regards to proportion of or penetration of LLMs to the user basis, it seems that the combination of OpenAI and Microsoft Copilot, that is an alliance, they account for more than 74% of the users. And if we add then Gemini and Claude, etc., we are talking about dominance. Recently, Chinese model seemed to increase participation, like DeepSeek, like QWen, etc. And the investment has been huge in the United States. It is evident that we need investments in order to develop a local ecosystem. Now we have another example of sovereign AI that seems to be very upcoming and successful, which is the Chinese one, which is driven by the state. And there is a very strong commitment and very long-term commitment by the Chinese government for AI. They face a challenge that there is this US policy that they don't allow the best chips of NVIDIA to be exported. So this is, of course, negative for them, but it gave them the possibility of, first of all, trying to improve training strategies and pipelines using lower-end GPUs, like DeepSeek, for instance. Their model is very much lighter than the dinosaurs of OpenAI. And also there is, as we will see later, which is here, we have Huawei that is creating GPUs. Some of them, they are competitive to the 2 to 3 years previous generation GPUs of NVIDIA. The foundation models of Chinese AI, they are very successful in China apparently because because of the wall of China, the firewall. You can only use local, and we know that the government is using LLMs, the industry is using LLMs, and here we have significant development. We have the Ernie by Baidu, DeepSeek, which is very popular in the West as well, with very high performance in reasoning tasks, and it is also very efficient. And we have also QN by Alibaba, Dubao by ByteDance, who is the owner of TikTok, and ChatGLM that I will present a slide later on by C4AI, that is a startup close in the ecosystem of Tsinghua University, which is the most important one in China. With regards to the chips, we already discussed that there is development by Huawei and SMIC, which is a sovereign national company. For the regulation, they have a very strict regulation framework about data and what is permitted or not. And the data say that the AI is very much diffused in the Chinese society and industry. A few words about GLM by ZAI, which is the startup next to Tsinghua. It was released very recently. It has very competitive performance on par with the best models of the West as well. And it has some significant advantages, like it can work with very long context, up to 200,000 tokens, which means that you can really prompt with a book. And it has very strong coding and development of workflow capabilities. I will not go into details. It has very advanced reasoning and agentic capabilities that are very important from now on. It produces text that is human-friendly and it is adapted to the context. And the most important is that it is open weight, accessible, and cost-effective, so it can be used for sovereign development. I will spend one slide as well for the efforts of United Arab Emirates. As I mentioned in the beginning, I am also partially affiliated to MBZ UAI, which is a new, very dynamic university founded 5 years ago or a bit more in the UAE, in Abu Dhabi. And it's already in the top positions in the rankings of AI. So it was a national commitment for AI because UAE was based on the petrol economy. They decided to diversify, and AI and high-end technology is one of those areas. So there is an investment of more than 300 billion dirhams, which is the local currency, and it is about $1 to 4 dirhams. They apparently know that they cannot develop in the short term their own GPUs, but they made important alliances with Microsoft and NVIDIA via their national state technology partner, which is called C42. They have invested in sovereign language models like JACE, in which we are involved as well, which is a model locally developed from scratch that focuses on English and Standard Arabic. And also there is Falcon that is developed by the TII Research Center, which is very close to MBZ UAI topologically. And they are also, this is also a very competitive model. Currently, there is an effort on integrating dialects, and this will be the second part of my talk, They have a very important and strong commitment on data local policy. So whatever data is produced in UAE is controlled 100%. Via MBZ UAI and other organizations, they are trying to attract international talent fastly. And also the regulation and governance is flexible so that they can attract foreign companies to do AI locally. This slide is about how much intensive is development of LLMs. And we see that the new versions of models, they are extremely, I cannot even remember how to pronounce this in terms of trillions, zillions, etc. So this is floating point operations. So this is a huge amount of, can we continue like this? Apparently not, because of energy, because very few entities can train such models. Now we are seeking other architectures like MOE, mixture of architectures, mixture of experts, that can train smaller models to collaborate in solving big problems. These are the distribution of models per industry or per organization. We see that Google dominates the production of models. Meta follows. OpenAI produces less models, but they are very much popular. Why? Because you have ChatGPT, which is the interface, the chatbot that enables communication with the people, and this makes it. We have Claude by Anthropic, which is also integrated with Amazon. Then we have the Chinese models, Alibaba. We have Mistral, which is the French, let's say, national or the French effort, backed by the state as well. NVIDIA not only develops GPUs, but also models, Hugging Face, etc. Okay, so what is the development pipeline of an LLM? I guess it may be trivial for you, but I think it is good to use it as a hint for the next slides. We need language data, we need algorithms, we need the computing resources, and this is for the pre-training. Probably we don't need to do it. And then if we assume that we have this model, we do the post-training that has to do with supervised fine-tuning that includes local data, and we will explain a bit later that the supervised fine-tuning needs to be followed by reinforcement learning so that the model is aligned. Here are the different steps: data collection, sovereign data. Localization of the data is mandatory. So we have to make sure that the cleaning, the duplication, transformation, by experience, more than 80 or 90% of the time and the efforts that we spend for an LLM have to do with data collection, data cleaning, and instruction preparation. So it is important that the data stays where they are controlled. The model acquisition, as we mentioned, it is probably more convenient to choose an open model, and we can think about Llama, that are becoming now a little bit old, Mistral, which is the French one, Gemma, which is Google, Q1 or GLM, that are Chinese. So it is important that the model is open so that we don't rely on a foreign API for access or licensing. And then the fine-tuning and alignment needs to be done locally. Then, yes?
If you are taking a pre-trained model, and like if we go back to the first slide with like all the language contents like of English, so English is already like the majority
Exactly.
of all written contents.
Exactly.
Digital. If you are taking a pre-trained model, in a way, it is not kind of native in language. and then like post-training using another language maybe
Well,
just adds a layer?
yeah.
Or is this like
Usually,
some-
what we do, and I will show this in the Nile chat pipeline, we do continual pre-training, which means that we do some kind of continue the pre-training with local data. But we have to be careful, because if we do it only with local language data, there may be catastrophic forgetting. So there has to be a strategy on how to mix the data, on how to do curriculum learning, which means how to sequence the data from easy to difficult ones, so that your model learns the new language but doesn't forget all the previous, because all that it knew is not only English, it knew mathematics, it knew reasoning, etc.
Are you worried that like if we are using a pre-trained model that is like pre-training this data set that is majority English, it will, subtle way be kind of English speaker? I mean, like,
Well,
we know that our brains are like that, right? If you're born in one language,
yes. That's an interesting question. I mean, still the research is open, but we have experiences that, if you take an English-bred model, which is the majority, and then you train it only on local language, what you get in the end speaks only the local language, and sometimes it forgets apparently the English, but also the other capacities. So you have to teach the other capacities again. The other capacities may be, I mean, there must be some kind of transfer, like the math is the same all over the world. The ethics are not the same, right? Or the local, for instance, what is the best breakfast? If you ask the query in Sao Paulo, it may be café and pound de queso. If you ask this in Greece or in US, it will be a different question. So it is a matter of, pre-training or continual pre-training and aligning a model is kind of an art. There are no strict rules, and this is why you need genius engineers with experience to, because there are early signs that something doesn't go well.
I wanted to ask, who is supposed to be developing these AIs? Are we proposing that the government has to do it, or private initiative?
No, I mean, they can be done by anybody that has the resources. So the resources means many billions of tokens. The resources need to include some hundreds of GPUs for many thousands of hours, usually. You need skilled engineers, and you need a strong case. I mean, you need to need this model. You don't do it for fun because it's very costly. Okay, so if you have a big industry that is convinced that adapting, fine-tuning, or in general, adapting an LLM to its needs will be productive, yes, there is already companies that do it in the insurance, banks. They don't advertise it so much because they want to keep it inside, but yeah.
Let me ask a follow-up question, because I guess there is the sovereign thing that is learning from scratch, and this half sovereign,
Yes,
which is learning from
yes,
something else.
yes.
Do you feel this way or no? You feel like when you learn from something else, it's still sovereign in the end?
Well, I mean, if you get a model, of course, the definition of sovereignty is also, there is not a line that behind, or this line is not sovereign. It's not a 0-1. First of all, you cannot really be 100% sovereign on hardware unless you produce your own GPUs, which is very unlikely for the next several years. Second, if the model is open, which means that you have it locally, and you control, the weights. And so basically it is like a brain that you learn it, that you teach new capacities, new skills. It is like a young kid that only knows how to stand and eat, and then you teach it mathematics, you teach it I don't know, running, or you teach it how to socialize. This is what you do, basically. You have a base model, and there are different versions. There are the instruct models, which are instructed based on, so for instance, the Chinese models, there are two versions. There is the base one and the instructed one. The instructed one has been taught with the Chinese instructions. You can get the base one, and you can teach it with the Brazilian instructions, for instance. And the instructions is basically teaching the model different skills, mathematic, reasoning, etc. That is universal, for instance. But you can also have localized skills, like how do you get the driver's license? You can teach it local processes, local ethics, the local legal system, which is apparently different, okay? So this is, I don't know if it was covering your... and then you have the deployment and the inference phase, which is also very important because you want your model to be, first of all, safe. Safe means that it should not produce answers that are not allowed or are not permitted by any rules, governmental or ethical, okay? There was recently, like a few months ago or a year ago, this issue with the French model Lucy that was released before it was safety tuned enough. And some people were asking about Hitler and the Nazis, etc. And the answers were not aligned with political correctness of France. And for this reason, there was an attack of the press to the model, and it was withdrawn until. So when you release a model, you need to be sure that it is safety tuned, that it is not easy to jailbreak and make it, for instance, teach you how to build an atomic bomb or a Molotov bomb, etc. And many more, okay? The geopolitical situation of a country also dictates the answers of such models, you can understand, right? So the inference and deployment phase is important. So we need to have infrastructure that is able to handle many users, many queries. For instance, as an example, if we have 100 requests of 100 tokens per second for a 32 billion parameter model, we need 100 GPUs of 80 gigabytes each one to serve this traffic. And there are many decisions that you need to make, whether you will use the full weights or you will do quantization. A lot of engineering. Also, another important topic is the access to external sources via RAG that makes sure that your answers are updated to the current data and they don't reflect data of previous times. And then, of course, there are more systemic aspects like the governance of the model, which is to protect from external attacks, to monitor by logging all the prompts so that you know what. This is also a collection of data that are precious for the next generation of the model, because if you know what your users are asking and how do they interact with the model, this is important. And also there needs to be continuous maintenance if you want the model to be usable on a daily basis. We have only 10 minutes. I should make some choice for the slides, right?
Go up to fire, then have some questions.
Okay, then I have some slides about the alignment topic, because alignment means adapting to the context or to the local environment. So there are three characteristics here. The model has to be helpful, honest, and harmless. So for instance, if you have this query, what causes seasons to change, you can have this answer or that answer. So changes occur all the time, and it is an important aspect of life, which is not really informative. But then you have the seasons are caused primarily by the tilt of the Earth's axis, which is much more informative. So we should favor such answers. We need answers to be honest and also harmless. For instance, if you have this this Linux command will eliminate the drive, and the LLM must warn you for that, rather than encouraging you to eliminate your data. There's also cultural alignment. So, for instance, in ChatGPT, if you ask the query, tell me a joke about women, it will say that it is inappropriate. For whatever reasons, it was instructed to do that. But if you have the same about men, it will give a joke. We like it or not, this is how it was aligned. So the pipeline of alignment, it is that you take the baseline model and you teach it via many different, let's say, queries and answers, what kind of responses to prefer. And this is in the context of RLHF, which means reinforcement learning human feedback, that makes the models behave as we would wish them to behave. Economic impact of LLMs, I think it's a lot of text. It is evident that the economic impact of developing sovereign AI is significant, especially if it is like a snowball that increases and creates an activity that creates, local talent, local data, local industry, and added value. There are also some downsides. At the level of labor and skills, many people we expect to lose their jobs because of automation, and the governments must have policies on what to do with these people, how to retrain them. On the other hand, there will be new demand for other types of skills like data engineers, prompt engineers. How to prompt an LLM, it has become a science. It is not simply interacting. How to prompt an LLM, it has become a science, because in the end, it is like, the internal structure of the LLM, how it was trained, so that you can interact in ways that the LLM will give you the best you expect. And then for the last 5 minutes, I will give you some experiences from the two models that we developed in the context of the Paris lab of Vazirgiannis with our group. The thing is that the Arabic language is mostly dialectical, which means that all the Arab nation speaks some dialects. The written language is common, but the spoken one is very different. So you see the English sentence, I don't know what to do, is written in different, I cannot read it, but you can see they are different. So in this case, the problem is that the dominant models, until recently, they were not good enough with dialects. So there was motivation to do that. The problem is that dialects are mostly spoken, so there is no digital content in digital text. There is limited availability of high-quality, large-scale data sets. The existing benchmarks for Arabic, they are designed for the standard language and not for the dialects. In this case, we made significant efforts. So for the Atlas, so we developed two models. The Atlas model, that is for the Moroccan dialect, the dialect of Morocco, which is called Darija, and for the Egyptian dialect. They are both relatively large countries. Morocco population is 45 million. Egypt population is more than 90 million, close to 100 million people. So we used transliteration, because the populations there, they are using both Latin characters, but also Arabic characters to communicate. So the same word can be written with Arabic characters or with Latin characters, and converting one to the other is called transliteration. sentiment analysis datasets and summarization. We also created synthetic data. In the end, we had about 500,000 instructions. For the Egyptian data, we had more time and more experience, so we created pre-training data, 1.15 billion tokens. We have created supervised fine-tuning instruction that was significant, about 1.8 million instructions, and we kept 200K samples for DPO, which means reinforcement learning, how to align the model to the local culture. These are the pipelines. For the Atlas chat, it was mostly fine-tuning. As you see, for the Nile chat, we were based in both cases on Gemma, which is a distilled version of Gemini. And we did, in the case of Nile chat, which is more interesting, we did continual pre-training and annealing. Then we did SFT. That costed, we used not a lot of computing resources. And then we did the DPO process on the Egyptian mixture with 0.2 million samples, and we have the Nile chat. One of the contributions is not only fine-tuning or training models for dialects, it is also creating datasets for which there can be comparisons, like benchmarks, okay? And this is also another contribution. It is not only the models, but also the datasets that can be used later on for comparison. I will not go through the exhaustive list. So we have created a lot of new datasets that can be used for benchmarking, a lot of experiments. So it seems that the Atlas, we produced 3 versions of Atlas. It was 2, 9, and 27 billion. The largest one is outperforming in almost all cases, in almost all datasets. And the same for Nile chat, because it is adapted to the Egyptian language. So what is the conclusion? We created 23 new benchmark datasets for Moroccan and Egyptian dialects. We produced 5 models, 3 for the Moroccan and 2 for the Egyptian one. The performances are very promising. We have a lot of downloads, like several months ago, it was almost 50,000 downloads of the model and the data, which means that there is a strong interest by the Arab users. So that was for Atlas, if I remember, and that is for Nile chat. And with the Atlas chat paper, we won the best paper award in the devoted workshop of calling. Now, at the end, we are also interested because I have members of my group that are Brazilian origin, a postdoc, and some interns. So what we do is that we are collecting original Portuguese data. The red ones are speech, like YouTube, podcasts, and radio samples that we transcribe them into written text. And currently, we are expecting, so it is about 4 million videos that we expect to give 3 to 3.5 billion tokens, podcasts that are expected to give about 93 million tokens, radio samples that are less, and there are some public books that we found that can give 3.5 billion tokens, and there are public datasets that we found, like the Jabuticaba dataset and this Plataforma de Diversidade Linguística Brasileira that can give also a lot of data. So we are happy to provide and share these datasets in a potential. So thank you very much. You can find all our production in our Hugging Face and our webpage. And this is Sara Carneiro, the Brazilian postdoc that she is with us. Thank you very much.
we have time for questions. I have lots of questions. So,
Welcome.
why did you choose Moroccan and Egyptian since you are in Abu Dhabi, right?
Yes.
And then let me ask one more thing about
Yes.
the Arabics. Are you doing all these tests in Abu Dhabi or in France? Because you need a lot of
Exactly.
compute. And what is the computing power that you
Yes.
actually use?
So the first one about the choice of dialects. In order to have more data, you needed to choose a dialect that is spoken by more people. So we started with Moroccan and Egypt, that are the largest populations. There is also Algeria, but it is not as open as the other two countries. United Arab Emirates, they are speaking the Gulf, let's say, dialect that is very close to the standard one. It is in the pipeline, actually. There are different dialects. The Levantine one that is in Lebanon and Syria. There is the Gulf dialect that is spoken by Saudi Arabia, UAE, etc. But we decided to start from the more populous ones so that we can achieve more data. The second question about the infrastructure, we are lucky that the university has access to ample clusters of hundreds or thousands of GPUs that we can access remotely, of course. So in this case, we were privileged. We didn't have any problems. But I have to say that the first model, the Atlas one, was fine-tuning. It was, I would say, restricted resources that we used. And the second one, NileSat, it didn't consume enormous, because we did, we conducted, I would say, a rather constrained pre-training, continual pre-training, and then the fine-tuning and the DPO, which are not very expensive.
Other questions? Hold on a second.
Thank you for the talk. And I've been discussing with some people on developing a center for fine-tuning or fine-tuning and reinforcement learning. So tell me about time and people. So how long does it take to for instance, the Atlas research and the Nile research?
Yeah.
And how long, who are these people? Can you do it with students and postdoc? Do you need, professionals that are in some way more, I don't know, committed or has, I don't know.
I understand.
All right, thank you.
Your question is very, very important, because we are not talking about a research project. We are talking about an engineering project. As I mentioned, our experience is that the vast majority of the time and the resources goes to data collection, cleaning, the duplication, and the preparation of the data to be fed to the training mechanism or the fine-tuning mechanism. For this reason, you need skilled data engineers. I don't think it can be new PhD students. You need people that are understanding, and they are also getting updated on new technologies, on new methods, because it's like a boiling technology. And regarding the time, it depends on the amount of people that you have, but also on how well organized is the project. In our case, we were a rather small group. In the beginning, we were 3 to 5 people fully devoted to that. In the second case, it was more 9 to 10 people. And we produced these two models within, I would say, 16 months, both of them. But the people were devoted 100%. The people were devoted 100% and very hardworking. And also the management of the team is very important. There needs to be weekly meetings. There needs to be a Notion tool or other tool that you assign tasks to specific people and groups, and then they come back with the results. There is a pipeline because each process needs output of another. So the project management is important there.
I would add a little bit to his question. Thank you for the talk, and I would like to know what kind of skills do you recommend for engineering in engineering school, and how should we prepare our students to?
Yes, I
to
think this
be
is
in
extremely
line.
important. The people need to understand very well deep learning and transformer architectures. This is critical. They need to be proficient with PyTorch and the programming environments. They need to be very skilled with data engineering. And then also hyperparameter tuning of these architectures is very important. How to find the good parameters so that you have good convergence. And also some persistence on the experimental evaluations with the benchmarking data sets that is important so that your model can be compared to other models, and in the end you can have a competitive model that you can publish, that you can advertise. And also it is important to have you know, the domain has become so big that you now have engineers that are specialized in data engineering, engineers that are specialized on how to run the fine-tuning or the pre-training process, engineers that are specialized on how to integrate RAG, on how to do safety tuning. So I mean, it could take a longer time to discuss, but there is this pipeline that is rather well defined. And if you want to have a large-scale effort, you need people that are specialized on each part of the pipeline. Something that is relevant is that in École Polytechnique, we are starting this year a master degree that is devoted to LLM engineering. So it will be a 2-year degree that will educate. And something which is also important and let's say relevant in MBZU-AI, there was a decision to start a bachelor devoted in AI from day one. So it's a 4-year program that you are, let's say, teaching to the audience, to the people, the fundamental, of course, but you don't spend 2 years teaching mathematics and statistics and all that. You do the necessary, and then you, from the first year, you teach machine learning, second year, deep learning. We have LLM courses. We have DevOps courses. DevOps in the sense that how do you deploy a model? How do you make a model serve with many users and all that? But I know that in Brazil, there is great talent. I was discussing before with Professor Gossman that systematically in our classes in Polytechnique, we have in the top 10 students systematically people from USP. So I think there is no problem. The challenge is to schedule the courses, to have the good syllabus, access to some GPUs apparently. And of course, something that we find very useful is that the means of evaluation in these courses, it is much better if it is in terms of a data challenge. It doesn't make sense anymore to have a written exam on this. So what we do is that we give a data challenge project to our students. They work for that during 6 or 8 weeks in groups of 2 or 3, and then they come. There is the leaderboard in the Kaggle, and then they present their solution and they defend what they did. And I think, based on their evaluations as well, that this is the most important part of the course, how to devote a long-term, let's say, effort to a large problem in a group manner, so that you really experience the whole pipeline of data to machine learning, deep learning, how to test the model, etc. And this gives the self-confidence to the people that they can handle large-scale projects as well.
Thank you very much for the talk. Just 2 questions. One, which one was the base model that you used for?
It was Gemma.
Gemma, okay. And the second question, I think you just
That was a decision we took locally at that time. Now it might have been different.
okay. And the second one is you mentioned that like benchmarks are important to compare the models that you get with other models. How these two compare?
The benchmarks are data sets that contain questions and answers, for instance, in the local language. Okay, and this is a big effort as well. You need a lot of human effort to build high quality such benchmarks that are adapted to the local language, culture, etc.
No. Actually, my question is like how they perform in other benchmarks that like
Yes,
like in comparison with like I don't
yes,
know GPT or.
Wait. Here we have. I skipped a lot. So we are comparing with
Okay.
open source models and models that are specialized on Arabic, like ACE, JACE, Gemma, and these were the open models that were oriented towards Arabic. And then let me see. This is the Egyptian one. There are also translation challenges or data sets. I am sure that there are also results that are beyond the dialect, but also they are for Arabic or English. The only thing they are in the paper, but not here. I am sure that we have done a more wide experimentation. The objective here was to find out how can we build a better dialectical model. And these data sets are not only language, it is also for math, for reasoning, etc., but in the local language.
Mm-hmm. Yeah, I think it would be nice to see how like the base, how your model compare at least with the base model in like kind of.
Yes, here you have Gemma 3, for instance, and here you have Nile Chat. So this is the base model, and this is the model that was based on Gemma, and we see, for instance, from 50, 72, we go to 62, 62, 59, etc. So there is always, I mean, if you teach the model, it will learn if you teach it properly.
Well, I guess we are on time. I mean, we need to take the coffee break. But well, I have more questions. I guess other people have more questions, so we can talk during the break. Okay, thank you a lot. Thanks a lot.
Thank you very much.